Okay, so I gave you this question at the end of the previous video, which is really simple. I believe it's really easy. I don't look down on you, but just to make sure, just to start a new topic, I wanted to have you think about this. Okay, the answer is like even number includes 2, 4, 6. So you have to sum 3 probabilities, right? That is 53.5%. That's the probability of even numbers. So what I want to think about here is that, like, as a function, probability is a function, and outcome is obvious. Outcome is like probability, but what is the input? So previously I said as if the input is an outcome, but actually in this case, input is not one outcome. It is a set of outcomes, bunch of outcomes, right? So mathematically we have to distinguish them. So you may, if you think that probability is defined on 6 different outcomes, that's not right. Mathematically, that is not correct. That's so we have to think about probability on multiple outcomes. Before doing that, short digression. So probability, you may write it as 20% or 0.2 or 2/10 or 2 over 10, all correct. And I'm going to switch between them without saying anything, right? Should be straightforward, I believe, right? And I like, so percentage is a unit for, like, say, fraction, like, or proportion, right? So, but it's a unit, but it makes confusion. I recommend you to think about 0.2 or think the probability as 0.2 or 2 over 10, right? Fraction would be better because, like, for example, when you multiply two probabilities, 20% times 30% is not 600% because the unit does not match, right? So the right way to calculate this is 20% is 0.2, 30% is 0.3, so multiply them, it's 0.06, so it's only 6%, right? So because this conversion is confusing, I understand it's not about your mathematical skills or how smart you are. Anyone can be confused. So just have a habit, build a habit to avoid percentage in algebra, just to prevent confusion in advance. Anyhow, back to the original discussion. I want you to think it as a function, think the probability as a function, and then what is the domain? I said as if the domain is sample space, but actually it can be more than that. So the probability is assigned to an event, and event is a set of outcomes, right? So we define probability not a single outcome, but like multiple outcomes at the same time together, right? That is difference. But also later, when there are infinite number of possible outcomes, this will become more important. Later, single outcome doesn't mean anything because they are infinite. So you have to think about like a set that is the event. So, but for now, just its conceptual distinction and counting outcomes is enough, right? Like this, just count which outcome included in the event and sum those probabilities. That's a correct way, fundamental way to calculate probability of any event. The distinction is particularly important when you have multiple variables, right? So I will show you actual data. This is from NLSY, United States National Longitudinal Study of Youth 1997 data. Right? I will open this. So I took just some variables, some key variables from the data: gender, birth year, race, region, education, marital status, employment status, health insurance coverage. So actual data, real data, the original data has many more variables, much more variables than these, but I just took simple, easy variables. So 1, 2, 3, 4, 5, 6, 7, 8. 8 variables. And to the bottom, there are 7,155. 7,000, more than 7,000 observations, right? Now, when you have this data, you have to think about, I want you to think about the underlying structure. It is a survey data. So random experiment is choosing a person. Randomly choose a young person living in the United States in 1997. Choose a person and ask 6 questions. What is your gender? What is your birth year? What is your race? What is your region of residence? What is your education? What is your marital status? What is your employment status? What is your health insurance coverage status? Like that, right? So 6 questions are answered from one person, and then that makes one experiment, right? So what the point here is, there are 6 variables, but they are from one experiment, one person. One person equals one experiment. So 6 variables are not from 6 different experiments. Then, like first person was female, born in 81, blah, blah, blah. And then after getting those answers, you discard, so choose another person, another random person. The second person is also female, 81, Hispanic, Northeast, so one person is one experiment. So this experiment was repeated more than 7,000 times. Huge number, right? So like this data tells you how many times you repeated an experiment. To think about that, you have to imagine what is the underlying experiment first, right? So there like one person is one experiment, that is the observational unit. So that is the basis of your analysis, okay? Right? So just back to the slides. Originally, this data set has like annual survey. So you survey, say, like 10,000 people in 97, and then next year visit them again, survey the same people again and again and again and again until like 2006 or later. It will maybe still it continues. So it is really valuable data. It's really hard to survey the same people every year, right? How many friends you meet every year, right? This survey finds those people every year and obtain like updated questions. Some of them may have died, right? Some of them may be out of sample in some years, but it's a very informative data set, huge data. And the attached data, the Excel spreadsheet is from 2006 survey. I just chose 1 year where like most of them are grown up, right? And the sample is limited to those who are born in 1980 to 1984. And after removing missing values, I deleted those who did not answer the questions. I got 7,000, more than 7,000 observations, right? And these are the underlying experiments. 8 questions, all right. Anyhow, so randomly choosing one person is an experiment, and ask 8 questions is just still 8 questions is a set, and that is one. That count as one observation. So one row is one experiment. One column is one variable. So it's different. They are different. The meaning of the row and column is different. And then, again, this is the original data, raw data. You cannot present 7,000 people like this. It's not informative. They're just bunch of numbers. But from these numbers, I cannot tell like what is the average education and what is the unemployment rate. You have to summarize them for presentation. So I'm going to show you really important technique you have to know in Excel. Like so, this is the basic data. Click Insert tab and use pivot table function. This is the one of the most important function you have to learn in Excel, but many of you do not know this, I guess. So just click it. Simple. Choose the data area. It's automatically chosen, and just click OK. It's a area, data area, and I choose new worksheet. So new sheet will be made, and so then I have some blank thing. You have to choose the data you are going to study. Like for example, I'd like to study the gender and region. Say gender, when you click gender or like gender and region, when you click gender, it shows up here, right? Gender is added to rows. That means each row has one outcome from gender variable. And let's click, say, employment. Then another employment variable is added here. So one row is not only gender, but also a possible outcome in employment. So, but I'm going to drag and move it to column. Then you have 2 by 3 table. So 2 means that each row is each outcome from gender, and each column is each outcome from possible outcome from employment status. Employed, not in labor force, and unemployed. And you just drag anything to value. So then value is the frequency. Here it says count how many observation count in each category, right? So out of 7,154, 2,705 are female and employed, right? And 2,753 are male and employed. Like that, there are 6 different categories and calculated the count. But we would like to transform these numbers into percentage. So these are count up. One more thing. So as you can see, like here, grand total is sum of these two, sum of these two, sum of these two. So regardless of gender, you can calculate how many are unemployed. Out of 7,154, 582 are unemployed. If you don't care about gender, just care about employment status, this tells you the numbers. And these are the total number of female, total number of male, regardless of employment. So now let's convert those count into probabilities. You have to come here. Let me hide my face. So you click this drop down menu and choose value field settings. And then you may change the count to sum or average, max, mean, up to you, depending on what you want. Here, your standard deviation, variance. But what we actually want is the probability is a kind of count based on count, and it's click this tab. Just keep it as count and click the second tab, and then you calculate the value as percentage of grand total, right? So then you are going to get probabilities. This is how you calculate probability based on multiple outcomes. right? Using pivot table on Excel. So it tells you exactly what you want. Say 4.49% of observations are male unemployed people, and say 9.06% are female and not in labor force, right? So if you want to change to, say, marital status instead of uh, things, you may do the same thing. So depending, like you can see, there are 5 different marital status: divorced, married, never married, separated, widowed. So then like 0% widowed male, right? So this is how you use uh, pivot table on Excel. This is really useful, right? Uh, if you're study like so, also what you can do is you can make graph based on this, right? So you may choose like based on the pivot table, you may insert, say, like graph like pie graph like this, or bar graph as you want if you want. So it's no, it doesn't work. So you may use different types of graphs based on the pivot table, and also you can change the portion, something like that. So you can restrict the sample only to, say, non-married people, exclude married, then percentage changes, something like that. This is really useful tool. So I think this is more important than the underlying mathematical structure of probability. So back to slide. Okay, let's try this. Health insurance. I am going to delete these two, and let me delete chart. Health insurance coverage is here. I put health insurance variable here and count here. This is the count. 4,744 people have health insurance. So count that, calculate that as percentage. Then 66.31% has health insurance covered, but 33.69% are not. So this is calculated, summarizing the data this way. And one more variable, you can, because you have multiple variables, you can add a gender. I will bring gender to column. Then automatically it becomes 2x2, two-dimensional table. So female without health insurance, male without health insurance, female with health insurance, male without with health insurance, like that. So you have new 2x2 numbers like this. Okay. So in this video, we learned how to use pivot table on Excel. Now then, continue from here. Think about this. Suppose that we have only 2 variables. I will ignore all the other variables. We are interested only in health insurance and gender. So given this table, given these 2 variables only, how many outcomes you have in the sample space? Think about this, and I will come back in the next video. Right? Think about this more carefully before starting the next one. Thank you for watching. See you later.